A bald eagle has a wingspan wider than you are tall. It has talons that can exert enough force to crush bone and eyes that can pick out a fish from half a mile up. It sits comfortably at the top of its food chain, with essentially nothing in its environment that hunts it, and you can watch one get chased across the sky by a bird that weighs about as much as a can of soup. The eagle does not fight back. It does not turn and grab the crow, which it is fully capable of doing. It flaps away, awkward and harassed, while the crow rides above it screaming and occasionally dropping down to strike at its head and back. Sometimes there are two crows. Sometimes there are 20. The eagle leaves. This happens to hawks. It happens to owls. It happens to ospreys and falcons and vultures. It happens to foxes, cats, and coyotes on the ground. And if you spend enough time watching, you start to notice that the same thing happens to humans, which is where the story gets substantially stranger. Let's dig into this properly, because the first thing to sort out is whether afraid is even the right word. It probably is not, and the distinction matters. A great horned owl is not lying awake worrying about crows. If an owl gets its talons on a crow, the crow dies immediately, and the fight is over. In a straight physical contest between one crow and almost any raptor, the crow loses badly. Nothing about crow anatomy is built for combat with a bird that outweighs it several times over and comes equipped with purpose-built killing hardware. What is actually happening is a calculation. And rather than fear in the emotional sense, actually what a harassed eagle is displaying is something closer to the reaction you would have to a wasp at a picnic. You are enormously stronger than the wasp. You leave anyway. The behavior has a name. Biologists call it mobbing, and it appears across an enormous range of species. Songbirds, gulls, terns, ground squirrels, meerkats, even some fish. Prey animals approach a predator, make themselves loud and conspicuous, and harass it until it leaves. On its face, this looks suicidal. Walking up to something that eats you and shouting at it is not obviously a winning strategy. So why does it work, and why are corvids so exceptionally good at it? Start with the physics, because that part is underrated. Crows are small, light, and absurdly maneuverable. A crow can change direction faster than an eagle can track it, and critically, a crow can operate comfortably above a larger bird. Attacking from above is the whole trick. A soaring raptor's defenses face forward and down towards the prey it hunts. Its blind spot is directly behind and above, and a crow that stays in that zone can strike repeatedly while remaining nearly impossible to counterattack. To retaliate, the eagle would have to roll, flip, or stall, dumping altitude and speed to swipe at a target that will simply move. Meanwhile, the crow's flight costs are tiny compared to the eagle's. Every second of this exchange is expensive for the big bird and cheap for the small one. Then there is the specific target crows aim for. Mobbing corvids concentrate on the head and particularly the eyes. A raptor's eyes are its entire livelihood. An eagle with a damaged eye cannot hunt and will starve. The risk of taking a beak strike to the face over a squabble with a bird it does not even want to eat is a terrible trade. Leaving costs the eagle a few minutes and some dignity. Staying risks its ability to feed itself for the rest of its life. Let's talk about why the crows bother too, because this represents the other half of the equation, and it is not just territorial irritation. Crows have very good reasons to want raptors gone. Great horned owls are among the most serious threats a crow faces, and they hunt at night when crows are roosting and effectively helpless. A crow cannot fight an owl in the dark. What it can do is find that owl during the day, when the owl is sluggish and light-sensitive, and the crow has every advantage, and make its life unpleasant enough that it relocates. Daytime mobbing of owls is often less about the current moment, and more about tonight. The intensity of anti-owl mobbing is worth noticing on its own. Birders and researchers alike use it as a detection method. If you hear a sustained corvid uproar concentrated in one tree, there is a very good chance an owl is sitting in it. Some owls respond by pressing themselves flat against a trunk, elongating their bodies and closing their eyes to slits, relying on camouflage rather than flight. Some abandon the position entirely and take off, which frequently makes things worse, since a flying owl in daylight attracts an even larger crowd. The asymmetry between day and night in this relationship is close to total. After dark, the owl holds every advantage: silent flight, exceptional low light vision, and hearing precise enough to locate prey it cannot see. In daylight, that entire toolkit is worth very little, and the owl becomes a slow, conspicuous target sitting in the open. Crows exploit that window with what looks a great deal like deliberate scheduling. There is also the nest. Crow eggs and nestlings are attractive food for hawks, ravens, and other predators, and a crow pair breeding in an area has an enormous stake in keeping that area predator-free. Mobbing intensity spikes sharply during breeding season for exactly that reason. And there is information. A mobbing event is loud, and it is loud on purpose. The calls broadcast to every crow in earshot that there is a predator at this location, and other crows come. This is why mobs grow. A single crow starts, a few join, and within a minute you can have a substantial crowd. The predator is now dealing with a coordinated, noisy, three-dimensional problem, and crucially, it has lost the element of surprise. A hunter that everything nearby has been told about is a hunter that is not going to catch anything. Even if the raptor stands its ground, the mob has already taken away its meal. Let's talk about the calls themselves too, because this represents a level of sophistication that is easy to miss when all you hear is noise. Crow vocalizations are not one undifferentiated racket. Researchers who have spent time analyzing corvid calls describe distinct call types used in different contexts, including a harsh, rapid, repeated scold associated specifically with mobbing. The structure of these calls seems to carry information about urgency. And in some corvid species, the calling pattern differs depending on the kind of threat present, a difference in rhythm and repetition rate rather than in the words, so to speak. Mobbing calls also have an acoustic property that suits their job perfectly. They are broadband, repetitive, and abrupt, which makes them extremely easy to locate. That is the opposite of what an alarm call is when a bird wants to warn its family without giving away its own position. Those tend to be thin, high, pure tones that are hard to pinpoint. A mobbing call is designed to be found. The whole point is to summon a crowd and to make certain the predator knows it has been seen. And the crowd that assembles is frequently not all crows. Mobbing is one of the clearest examples of animals eavesdropping across species lines. Chickadees, jays, titmice, blackbirds, and various songbirds recognize corvid mobbing calls and often join in, and the reverse happens too. A hawk sitting quietly in a tree can end up surrounded by 5 or 6 different species, all of which learned about it from the first bird that spotted it. Some of these species are on the crow's own menu under other circumstances, which produces the odd spectacle of a temporary alliance between animals that would otherwise be avoiding each other. That cross-species dimension multiplies the effect enormously. A predator has not just lost the element of surprise with one species, it has lost it with the entire local community at once, and that community will continue advertising its position for as long as it stays. That combination, cheap for the harasser, expensive and futile for the predator, is why mobbing persists as a strategy, but it does not explain why corvids in particular have become so notorious for it. Plenty of birds mob. Crows and ravens and magpies do it with a level of persistence, coordination, and apparent grudge-holding that puts them in their own category. This detail is worth sitting with directly, because the answer runs straight into one of the most surprising findings in animal cognition. Bird brains are small. For a long time, that was taken to mean bird intelligence had a hard ceiling, and the phrase bird brain reflects exactly that assumption. What research over the past few decades established is that the assumption was based on a bad measurement. Bird forebrains pack neurons far more densely than mammal brains do. A corvid brain, despite being a fraction of the size of a monkey's, can contain a comparable number of neurons in the regions associated with complex cognition. Birds also lack a neocortex, the layered structure that handles higher processing in mammals, which was long treated as evidence that they could not do sophisticated thinking. Instead, they have a region called the nidopallium caudolaterale, which appears to perform many of the same functions through a completely different architecture. Two lineages separated by hundreds of millions of years arrived at flexible intelligence by different structural routes. The behavioral evidence lines up. New Caledonian crows manufacture hooked tools from twigs and pandanus leaves, use them to extract grubs, and modify tool designs. Crows in captivity have solved multi-step puzzles requiring them to use one tool to obtain another. Corvids cache food, remember thousands of cache locations, and rehide food if they were watched while caching, which suggests some sense of what another individual can see. Some corvids will pass up an immediate small reward for a better one later. But for the purposes of understanding predator harassment, the most relevant finding involves faces. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. Researchers at a university in the American Pacific Northwest ran a now famous series of experiments. Wearing a distinctive mask, they captured and banded wild crows, then released them. Afterward, people walked the campus wearing either that mask or a different one. The crows scolded and mobbed the mask associated with capture. They ignored the other one. Same clothes, same gait, same route, different face, completely different reaction. The crows had learned a specific individual face and attached a threat to it. Then the results got considerably more interesting. The mobbing response spread to crows that had never been captured, including birds that were not even alive at the time of the original trapping. Young crows learned the dangerous face from the reaction of adults around them, and the response persisted for years, long after the original trapping events, with the number of birds responding actually growing over time as the information propagated through the population. That is socially transmitted, individually specific threat information with a multi-year lifespan. In practical terms, a crow population maintains something like a shared list of who is dangerous and updates it by watching each other. Let's talk about what that means for a hawk too, because this represents the core of the answer. A resident predator in crow territory does not face a series of independent encounters. It faces an environment that remembers it. If a red-tailed hawk takes a crow fledgling, the crows in that area do not simply react in the moment and then forget. They learn that hawk, that location, that pattern. Subsequent hunting attempts in the same area meet faster, larger, better organized responses. The hawk's hunting efficiency in that territory degrades, and the rational move is to hunt somewhere quieter. That is a real cost imposed on an apex predator by a much weaker animal, achieved entirely through information, coordination, and memory rather than through force. Let's talk about the relationship from the other direction too, because this represents a side of it that complicates the simple story of harassment. Corvids and large predators are not purely antagonistic. Ravens in particular have an extensively documented relationship with wolves. Ravens follow wolf packs, feed at wolf kills, and appear at carcasses with remarkable speed. Wolves can open a large carcass in a way a raven's beak cannot, so ravens benefit enormously from being nearby when wolves are hunting. Researchers studying wolves have noted that ravens sometimes arrive at a fresh kill within minutes. There is a long-standing and more contested claim that ravens actively lead wolves to prey or carcasses, calling to attract them. Some field researchers have reported behavior consistent with this and describe it as a working partnership. Others argue the evidence is mostly anecdotal and that a simpler explanation, ravens are excellent at spotting wolf activity and following it, accounts for what is observed without requiring intentional recruitment. The question remains open, and it is worth being honest that this is an unresolved debate rather than settled fact. What is well documented is that ravens harass wolves at carcasses, tug their tails, and steal meat directly, and that wolves largely tolerate it. Ravens can remove a substantial share of a carcass over time. Some researchers have argued this pressure is one reason wolves benefit from hunting in larger packs. A bigger group consumes a kill faster and loses less of it to scavengers. So the same bird that harasses an eagle out of the sky also functions as an opportunistic partner to a wolf pack. Both behaviors come from the same underlying capability, paying close attention to what large dangerous animals are doing and acting on that information. Let's talk about numbers too, because this represents a factor that turns individual crow cleverness into something a predator cannot ignore. Outside of breeding season, crows gather in communal roosts, and those roosts can be extraordinary. Wintering roosts numbering in the tens of thousands are documented in various parts of North America, and historical accounts describe some considerably larger. The birds disperse during the day to forage across a wide area and stream back to the same location at dusk, often following consistent flight paths that people living nearby learn to recognize. The reasons for roosting this way are debated and probably multiple. Safety from nocturnal predators is one. An owl approaching a roost of thousands has very little chance of surprising anyone, and there are always birds awake. Warmth is another, especially in cold climates. And there is a plausible information angle, sometimes described as an information center effect, where birds that fed poorly follow better fed birds out in the morning and gain access to food sources they did not find themselves. The evidence for that last one is mixed, and researchers disagree about how much of it actually operates in crows. Whatever the mix of reasons, the effect on predator relations is direct. A crow that gets into trouble is rarely far from a very large number of other crows, and the response to a distress or mobbing call can escalate faster than a raptor can react. Crows have also moved into cities in enormous numbers, and urban environments suit them almost perfectly. Cities offer abundant discarded food, plentiful nesting structures, warmth, artificial light that extends foraging hours, and far fewer large raptors than open country. Where raptors have followed them in, notably peregrine falcons and various hawks that adapted to nesting on tall buildings, the same harassment dynamics play out against a backdrop of traffic and rooftops. Let's also talk about the human side of this, because this represents the part most people can actually verify themselves. Crows in cities live alongside the single most dangerous species on the planet and have adapted by treating individual humans as individual entities rather than as an undifferentiated category. There are well-documented cases of crow populations reliably mobbing particular people while ignoring everyone else nearby, typically people who at some point interfered with a nest or handled a bird. There are equally documented cases running the other way. People who feed crows regularly have reported the birds bringing small objects and leaving them where the food is placed. Bits of metal, glass, buttons. Whether this constitutes deliberate gift-giving or is a byproduct of foraging and caching behavior is debated among researchers, and confident claims in either direction go beyond what the evidence supports. What is not debated is that crows distinguish reliably between individual humans and adjust their behavior accordingly. Crows also gather around dead crows in what have been described as funerals. Careful experimental work suggests these gatherings function as danger learning events rather than mourning. The birds are studying the scene, associating the location, and any nearby predator or person with lethal risk, and then avoiding that association afterward. Alarm and information, rather than grief, appear to be what is happening. The behavior turns a single crow's death into a lesson learned by the whole local population. Let's zoom out and pull all of these different threads together. The premise in the question contains a small error worth correcting directly. Apex predators are not afraid of crows in any meaningful sense. An eagle could kill a crow in a second, and both animals know it. What the eagle is responding to is a cost structure that makes fighting a bad idea. The crow is fast, maneuverable, hard to hit, and aiming at the one part of the eagle's body that cannot afford damage. The crow can leave whenever it wants, and has friends arriving. The eagle gains nothing from winning and loses meaningfully from any injury. Every incentive points toward leaving. There is one more wrinkle in the cost structure. A raptor that does decide to fight back has to catch the crow first, and the attempt itself is revealing. Video and field observations of raptors turning on mobbing corvids show a consistent pattern. The crow simply climbs, and the raptor cannot follow at the same rate while carrying its own mass. The pursuit burns energy the predator needs for hunting, produces no result, and leaves it lower and slower than it started. On the rare occasions a large raptor does connect, the crow usually dies, which is precisely why crows almost never let it happen, and why mobbing is conducted at a careful distance with strikes that are more feint than contact. Layered on top of that is the thing that makes corvids exceptional rather than merely annoying: memory that lasts for years, recognition of specific individuals rather than general categories, and social transmission that spreads a threat assessment through a population without every bird needing to experience the threat directly. A predator in crow country is not dealing with a bird. It is dealing with a distributed information network that has already told everyone what it looks like. That capacity is why the arrangement holds so consistently. Raw physical power settles a single encounter. It does very little against an opponent that refuses to have the encounter, remembers your face, and tells its neighbors. Which leaves an interesting thought worth sitting with. The animal at the top of the food chain is defined by having nothing that can kill it. And it turns out that being unkillable and being left alone are two entirely different things.